Hello, Legacy students. Today we're going to look at graphing piecewise functions. You're going to want to have on you today your notes and those little graph paper squares I gave you, pencils, and then also a calculator today. Your learning target. Given a piecewise equation, I can graph the function. So basically, remember, a piecewise function is it's a function that's made up of pieces of different functions which result in different domains, or your x values. These are not inequalities. There is no shading or dashed lines. They're just simply pieces of different graphs. So remember also, f of x is read f of x, just like y. So we need to be able to graph these particular functions. Now, they're kind of difficult, so bear with me so far, okay? So here's what you're going to want to first do. You're going to want to graph the first function. So we're going to graph this guy first. So 1x minus 4. We're not even going to care about this if yet. We're just going to graph the function. So x minus 4. Where would we graph that? Well, we're going to start at the y-intercept of negative 4, right? So right here, and then I'm going to go up 1 over 1. Now, I'm just going to put dots. Don't fill in the line yet. Just put dots. Put some dots. There we go. Now, this is when that if comes into play. We only want this function to be present when x is less than 3. So it can't be when x is greater than 3. It has to be less than 3. So on the x-axis, I'm going to go to 3. And I need to think, which side of my function do I get to keep? Do I get to keep the left of that or the right of that? Well, I want less than 3, right? So I want to keep the left side, right? Because I want it to be smaller than 3. So I'd want the 2, 1, 0, stuff like that. So what I'm going to do, with my eraser, I'm going to erase the pieces that are not smaller than 3. So I'm going to get rid of those dots there. Now, I now get to connect my dots. Ooh, that's actually pretty good. Now, what kind of dot are we going to have at 3? Now, it can either be closed or open. If you've seen those graphs, you've seen that they can be closed or open. Well, I am not equal to 3, right? I'm less than 3. So at 3, we need a big open dot to be sitting right there. So that way we notice it's not closed, it's open. Now, we've graphed one of the pieces of my function. Let's graph the other piece. So I need to graph this guy second. So 2x plus 1. Let's graph him like we normally would have. So I'm going to start with my y-intercept of 1. Whoops. And then go up 2 over 1, up 2 over 1. Now, notice again, I'm not filling in my graph at all. I'm just filling in where my dots would go. Now, I need to keep what's bigger than 3, right? It tells me bigger than 3. So instead of going this side, I need to go on this side of 3. So I get to erase the side that I don't want. I don't want the left side, so I get to erase these dots here. There we go. Let's get back to my pen. Now, I need to graph the pieces that I still can use. This piece. I'm going to have a closed dot at 3 because, notice, it's equal to. So then I get to close my dot. I have finished my function. It is graphed perfectly. Trust me, it's hard, but you need to make sure that you can erase. I like the graph erase method. Let's try these. I have absolute value of x minus 3 when x is less than 5, and 1/2 x minus 2 if x is less than or equal to 5, or greater than or equal to 5. Let's graph the absolute value. So we know it's going to be to the right 3, because it's opposite of what you think, right? So right 3, and then I'm going to go up 1 over 1. So I'm going to put a bunch of dots where it should be. There we go. So now, I want where x is less than 5. So I'm going to go to 5. Which side this guy am I going to keep? Am I going to keep this side, the right-hand side, or the left-hand side? Well, I want less than 5. I want to keep the less than 5 part, right? So I want to keep the left side, right? left side. So I'm going to erase the right-hand side. What kind of dot are we going to have at 5? Open or closed? Well, it's just less than, so we're going to have a big open dot at 5. Got the top done. Now, let me change my color. Let's do the second part right here. So 1/2 x minus 2. So I'm going to start at minus 2 on my y-axis. Looks like I got to go up 1 over 2. So I'm going to do that for a while here. Just put my dots in. There we go. Now, I need to keep the, which side? The left or the right? Notice, this doesn't go perfectly on 5, which really kind of stinks. But that's okay. It can happen. So I need to go greater than 5. So I need to keep this side of my function, right? So I'm going to start kind of graphing here. Kind of think, and it looks like it's going to start right there. Whoops. And go, right? Kind of at 5. So I get to erase that part. So, and then am I going to have a closed dot or open dot at 5? It's going to be closed because it's equal to 5. Here's another way. Oh, I never graphed actually my V. Silly Miss Marsh. Let's graph my V. Whoa, I got some curvy lines here. That's okay. There we go. Notice how I always erase what was below the last part. Because it's a function, you gotta pass the vertical line test. So you always know that each time you graph this, you can't have a function and a function below, because then you don't have a function on your piecewise. You need to always make sure that when this guy stops, another guy is gonna start. Let's try the last one. Graphing a step function. Step functions are a little different, but not too much. So we know we're going to start at 3. That's going to be on our y. Now, that's from 0 to 2. So I'm going to start here at 0, and I'm going to only go to 2. I'm going to have an open dot over here and a closed dot over there, right? From 0 to 2, I'm at 3. Let's continue. I'm going to graph this one in red. So I'm going to stay at 1, and that's from 2 to 4. So starting at 2, we're going to go to 4. Looks like I have an open dot at 2, because I'm just less than, not greater, not equal to, excuse me. And then I'm closed dot at 4. Notice how these two are not, one of them's closed and one of them's open. They can't be both closed, otherwise then we don't have a function. What about from 4 to 6? Let's graph with green. 4 to 6, I'm going to be at 5. So from 4, I'm going to be at 5. So starting at 4, and that's open dot, I'm going to be until I get to 6. Something like that. These are what's known as a step function because it looks like steps on a stairs. Notice how it just kind of goes up or goes down. That's a step function. It's a specific kind of piecewise that you may see on, let's say, an ACT or some kind of test like that. And trust me, we're going to get tons of practice on graphing piecewise functions. And with that, see you later, Sabers.